was going to go through with you. This is off of your homework. We did not do one like this yesterday, and it's kind of weird that they insert this in your homework. This was number 20 on page 203. So this was one of your homework problems from yesterday. As we look at this function, and I could just skip it, but we are going to see problems like this later on, so I figure we might as well go ahead and talk about it. I don't really know, like I said, I don't really know why they threw this in, because the whole section's about quadratics, and then they threw a cubic function in here, and there wasn't very many of them, 19 and 20. 20 is the only one on your homework that is like this. We talked about different types of factoring yesterday. So we talked about DOPS, we talked about products and sum, we talked about slide and divide. We could do GCF as well. We didn't really talk about GCF yesterday because we didn't have anything like that. But this one is 4 terms. It's a cubic polynomial. And whenever we do this, the factoring that we do here is to factor by grouping. And we're going to group these 4 terms into 2 groups of 2. And then I'm going to take a GCF out. Okay, and this is a factoring method that I think we've done before, but it's been a while, and it's probably not one we spend a lot of time with because we don't see one like this very often. But we're going to take the GCF out of the first 2 here, which is x squared. So that leaves me with 3x plus, and here's where you got to be careful. I have an x squared and I take an x squared out. So if I take x squared divided by x squared, then that just leaves me 1. So we don't just want to like make it disappear, because what we're basically saying is if I take this and distribute it back through, it would get me back to here. Okay. Out of the second group, I have a negative 12x minus 4. So in that case, I could take out a negative 4. And because they're both negative, we'll take out a negative and not a positive. And essentially, when I take this out, all I'm doing is dividing these 2 by this. So negative 12x divided by negative 4 would be 3x. And then negative 4 divided by negative 4 would be plus 1. Hey, when we factor by grouping then, we combine the outside parts together. And we leave the inside part. We don't do 2 of them. That's just the common factor that we have, 3x plus 1. Hey, and then here's where it gets a little bit different than what we've done. This is a cubic polynomial. Yesterday we focused on quadratics, and we said quadratics have 2 solutions. Well, this one, and what we'll find out later on, is that when it's cubic, then we could have up to 3 solutions, or 3 places that we're looking for. And so in this case, x squared minus 4 is DOPS, and we talked about DOPS yesterday. So this would be x minus 2, x plus 2, and 3x plus 1 equals 0. Okay, so then we set each one of those equal to 0. And we solve each one for x. So this would be x equals 2, x equals negative 2, and then over here we're going to subtract 1, and then we'll divide by 3. And those would be our 3 solutions. So it's quite a bit different than the other ones that we did yesterday, mainly because we get 3 solutions rather than 2, because it's a cubic polynomial. It did give you a hint to factor by grouping, but we didn't do anything like that yesterday. You could graph this one as well. I could graph this one And it's going to be one of those snake-like graphs that we talked about earlier in the semester. And it's going to cross the x-axis at those three places. And so if you go back to verify, if you did look at your graph, then those would be the three places that it would cross. Okay? So once again, trying to tie everything together. So that's the only problem on there like that. I didn't want you to get to be like that and say, Mr. Ruda didn't do anything like this, because I really didn't, because it's kind of weird that it fits in there. And so I wanted to kind of go through that with you. Okay. Any other questions from yesterday? You guys feel pretty good about solving and graphing and all of that? Okay, today we're going to do some more with quadratics. But we're going to focus on graphing them today. And you might say, well, we graphed them yesterday, which we did, but we really only used our calculator to graph them. And the only thing that we focused on yesterday was where does it cross the x-axis? Because yesterday was all about solving. And so when we are just focused on solving, the only thing that we necessarily care about is where did the graph cross the x-axis, okay? And what we said is it could cross it 2 times, it could cross it or touch it one place where it bounces, or it may not touch it at all, okay? So, if you write this as a ratio, then get the sum of the ratio related to it.
Well, I know how to do that, but I don't know how to do this.
Well, what you could also do is you remember you can cross multiply and verify that they are the same.
Yeah, but that's, I thought,
But there's just one ratio. You could reduce this,
that
okay?
would be wrong if I cross multiply and shows you that.
Well, then that wouldn't give me the ratio, but the fraction gives me a ratio, so that's why I put that on the board. So like,
No.
cross
Okay,
multiply
don't listen.
makes me say yes, no?
Is it in the group
And
chat?
then once I say yes or no,
I was about to say
then
nothing.
I always
Can you
In the
see
group chat is popping up for me.
a ratio.
Do you want to just put it in?
No, I don't want to do both.
Yeah. Or just send it to me, I don't care, I just don't have it either.
Because it should be the same thing. If you're saying yes, those two should be the same ratio.
It's like
So today we're going to get a little bit more specific about different parts of the graph, right? We know it's going to be a parabola because today we're going to look at quadratics, and so they're all going to be parabolas. Sometimes they'll open up, sometimes they'll open down. We have a lot of different things that we're going to look at. The parent function is y equals x squared. And that, kind of going back to last chapter, when we look at like the basic graph, that's what we always compare things back to, like y equals x squared. Y equals x squared has a vertex at 0, 0. It opens up. It's a U shape. And then obviously, as we talk about quadratics today, sometimes they're going to get wider, sometimes they're going to get skinnier, sometimes they'll flip upside down, sometimes they're going to be shifted left, right, up, or down. So a lot of different things can happen, but it all comes back to this parent function. There's 2 different forms that we're going to talk about today. The first one is what we call vertex form. And vertex form is pretty nice to graph because it gives us a lot of information right from the beginning. The generic form of vertex form looks like this. And this is kind of like what we saw with transformations last chapter when we talked about the number inside of here tells me it's going to move left or right, but it's going to be opposite. The number at the end is going to tell me how much it's going to move up or down, and it's going to be the same. And then in vertex form, we would also have an A value out in front. And the A value out in front right here tells me the bigger the number, the wider it will be, okay? The skinnier it'll be, And then the smaller number, like if we're talking about numbers like a half, a fourth, a third, anything between 0 and 1, it's going to make it wider. And if this is negative, then it's going to flip upside down. Okay, so that A value is going to tell us a lot of information as well. So I'm going to give you an example here of an equation in vertex form. And we're going to talk about the different things that are going on here. Based off what we talked about last week, and at the end of chapter 2, then what's the minus 1 going to do to my graph? Which way? Okay, horizontal. And it's going to be the opposite. Okay, so here it's going to go right 1, and it's going to go up 4. So my vertex will be 1, 4. Did you get her done? Okay. Hey, the A value of 2 tells us two things. It's going to open up. See ya, you bet. And it's going to stretch vertically by a factor of 2. And we know it opens up because it's positive. If it was negative, it would go down. Okay? And so just by looking at the equation immediately, we can answer a lot of different things. We kind of know what this is going to look like. So if we were to start kind of sketching some of this, first of all, one, 4 would be my vertex. That's where the graph comes down and hits and goes back up, or if it opened down, it would come up, hit it, and come back down, but we know this one opens up, so we know the parabola is going to kind of make a shape like this. Now, because our main focus today is graphing, we do want to be a little bit more specific, right? We're not just going to sketch a graph of this. We are going to get a little bit more specific. Like we want some points that are going to be on this graph. We can easily get that from our table, and we want to be able to graph it. The axis of symmetry is another main focus of today. The axis of symmetry is always going to be a vertical line, and it's going to come right down the middle of the graph. It's going to split it in half. We talked about symmetry a little bit last week at the end of chapter 2. It's always the same as the x value of the vertex. So if we said the vertex has an x value of 1, the axis of symmetry is x equals 1. And what that tells me is the axis of symmetry is always going to be a vertical line, and that vertical line is splitting the graph right down the middle. It's the line of symmetry for the graph. Hey, then we want to come up with some points. We always put the vertex in the middle of our table of values. And we want to find some points to the right, and we want to find some points to the left. We don't want to start like at 0, 0, because that's not going to be the middle of the graph. Right now, this is the middle of the graph. So I would pick a couple of points to the right, like for instance, 2 and 3. I would pick a couple of points to the left. So to the left of 0, or to the left of 1 would be 0 and -1. Just to kind of get some points so my graph is a little bit more accurate when I graph it. And you don't necessarily have to generate those on your own, right? I could plug 2 into this equation and I could get my y value, but what would be the easier way to get it? Just use our calculator, right? And so if we were to go put this into -112, negative 112 is going to be like all the way up here. Okay, and that's why, like I was saying, it's going to kind of go off the graph paper depending on how big your graph paper is. But here's where we can use the axis of symmetry. If 0 is at 6, I could reflect this over the line of symmetry, right? And 2 would also be at 6. So I could go over 2, and I could go up 6. That's what the line of symmetry allows me to do. And can I get that point off my table of values as well? Sure. But I think it's also important to understand how the line of symmetry works here. Okay? I could go over to 3, and I could reflect the other point over that line of symmetry. I know I didn't extend it all the way up, but it still works the same way. This line extends up forever. And then as I sketch this, there would be my problem. Okay. So kind of looking ahead to like our quiz this week. When we are graphing one and it's asking us for like all this information, then we want to be pretty accurate. If I'm just graphing it to get the x-intercepts, I don't have to be super accurate, right? I don't necessarily care about all these points. This one doesn't have an x-intercept, so that wouldn't really help us anyway. But if we're doing a problem where it's focused on the graphing part of it, then we want to kind of go through all of those different things. Okay, one last thing on this one here. On a lot of the problems today, and we did this a little bit last week, they're going to ask us for either a maximum or a minimum. This graph will not have both. All of these are going to be parabolas today because they're all quadratics, okay? And so it's either going to be a minimum or it's going to be a maximum. In this case, it would be a minimum, and it would not have a maximum because there is no high point. This graph is going to go up forever, so it's going to be one or the other. This one would be a minimum. And then remember that when we write this, the minimum is going to happen at y equals 4 when x is 1, or at x equals 1. So we're just taking that vertex, the 0.14, which is where it happens, okay? But when we talk about the minimum or the maximum value, we talk about the y value, because that is the lowest point. 4 is the lowest point that graph ever hits at. So we don't just write the ordered pair 1, 4. The 0.14 is the vertex, y equals 4 is the minimum, and it happens at x equals 1. So it's using all the information from the vertex, but we just write it a little bit differently. We want to say where does that minimum happen at, and that would be at y equals 4. Okay, so lots of little different parts to this, okay? And this one, I told you there's going to be two forms today. This is what we call vertex form, because I could look at the equation immediately, and I immediately knew what my vertex was, okay? And so that's why vertex is pretty nice. When it's in vertex form, I can get a lot of information very, very quickly, and then all I really need to use my calculator for is to get a couple of other points to help us graph it, and we're good to go. The second one that we're going to talk about is the way that quadratics are typically written. They're not always going to be written in this vertex form. We said 1, 4 is the vertex, so the axis of symmetry was just x equals 1. So I can take this x value and I can make it my axis of symmetry, or if I already know the axis of symmetry, that can be the x value of the vertex. So we can go either way with that. So this next one is what we call standard form. Standard form is basically what we saw yesterday. All of the quadratic equations that we saw yesterday that we solved were written in standard form. And so we have f of x equals x squared plus 10x plus 23. So it looks pretty familiar to us because we saw it a lot yesterday. The bad thing about standard form is I can't just look at this and say, boom, there's my vertex, like I would be able to on vertex form, okay? And unfortunately, this is probably the one that we're gonna see more than we will vertex form. It's not always gonna be written in the vertex form of the equation. So how do we get the vertex and the axis of symmetry and all of that stuff? Can we do it in our calculator? No doubt about it, okay? Absolutely, we can use our calculator, and I'm totally fine with that, but there's gonna be some times where we're gonna wanna know some of these tricks that I'm getting ready to show you to kind of get some of the points that we want. But your graphing calculator is gonna be a great tool to be able to use today, okay? The first thing I'm gonna start with is the axis of symmetry. There's a formula that we can use to get the axis of symmetry. So I'm going to put a star by that because if you'll have some problems that will just ask you what is the axis of symmetry. I can put it into my calculator and I can figure out what the axis of symmetry is from the calculator, but we can also do it by hand. And it's really fairly quick. And we're going to use our A, B, and C values like we did yesterday. Except we're not going to solve it. We're not doing the quadratic formula. We're using the A, B, and C values to determine what the axis of symmetry is going to be. So this would be negative 10 over 2 times 1. So x equals negative 5. So x equals negative 5 is my axis of symmetry. The next big thing that we want to find is the vertex. Okay, now, last problem that we did, we found the vertex first because it was in vertex form, right? And then we said, because I already know the vertex, the axis of symmetry is x equals whatever the x value is. If I go back to the problem that, so I already know the x value of the vertex. And if I had to come up with the y value, then we have two options, okay? I could plug it into the equation right here and get the y value, or I could even use my calculator. If I had to plug this in real quick, just to show you how this would work, negative 5 squared would be 25. So we're going to go negative 5 squared plus 10 times negative 5 plus 23. So this would become 25 minus 50, which would be negative 25, plus 23, which would be negative 2. Okay. And I know I keep saying this, but can I get the vertex from my calculator? Absolutely, okay? There's going to be some times where your axis of symmetry is going to be a fraction or a decimal. And so that's why knowing this rule right here is going to be really helpful, because when you look at it on your calculator, it might be something like 2.3 repeating, right? And that's not how we want to write the axis of symmetry. And so we have to know how to write it in that fraction form, and that would be the quick shortcut that we can use to get it there. Now, if I wanted to graph this and get some of the different pieces going on here, the one thing that I already know is my vertex is at negative 5, negative 2. We know that, and this is the one thing that the two forms do have in common, they have an a value, right? Here, the a value is 1, and it's positive 1. So that means my graph is going to open up. The only other thing that I'm going to do here is I'm going to graph this. And if I was going to graph this, here's probably the part that most people struggle with, is they try to get some points, right? And then they don't really know what points to use. And now, can I plug in 0? You can always plug in 0, but here 0 is not really going to be ideal, because 0 is going to be like all the way up here, 0 something, right? And so that's not going to be an ideal point to graph. We want points that are fairly close to this axis of symmetry. And we know the axis of symmetry is this line right here. X equals -5 that we found right at the very beginning of the problem. So I just need to come up with a couple of points. And this is where your calculator is going to be really, really helpful. Okay? You don't have to generate these points on your own. You have your calculator to help you out. And I've told -6 and -4 are both at -1. -3 is at 2. And this is at 2. And there's my parabola. Okay. I would say 5 points is probably a good place to go. The first point's always going to be your vertex. Okay, these 2 points, if you pick the next point to the right or to the left, they usually don't move very much. And so that's why I kind of like the next point to the right and to the left, just to kind of start to see how that graph is going to widen out and look at all the information about it. Okay, let's do one more. This one is also in standard form. Okay, and I'm going to add a couple of new things here. You won't do these things on every single problem, so that's why I haven't done them on the other ones that we've done. But you're going to have some different questions. And these are all questions that we've asked or answered before. But we're going to do it with parabolas today as well. All right, so we have standard form. Where you start at is kind of up to you. First of all, I'm going to start with my A value here. A is -1. That's kind of an important piece of information. I didn't really talk about it on the last one. I did towards the end. But the reason I start with that here and why it's an important piece of information, it's my A value, which is in front of x squared. And what that simply tells me is that this parabola is going to open down because it's negative, right? And the other two that we've done today both opened up. So that's the one's going to be a little bit different. The axis of symmetry this is my A value, this is my B value. So we're going to do -14 over 2 times -1, which is -14 over -2, which would be at 7. So my axis of symmetry would be x equals 7. And you might even just say, I'm going to go right to my calculator, and I'm okay with that, okay? I'm just showing you how you could do it by hand and get that number algebraically rather than relying on your calculator to do everything. If I wanted to do my I'm going to go ahead and draw in the axis of symmetry at x equals 7, which goes right down through the middle of the vertex. That's going to be the line that splits the graph in half. Okay, when we come up with our table of values, 7, 2 is going to be the point that we want in the middle, right? So I'm going to pick some points to the right and to the left. So I go 1 to the right, 2 to the right, 1 to the left, 2 to the left. Okay? And that gives me 2 quick and easy points that we're going to have here. And like I said, and there's our parabola. Yesterday, we focused on the x-intercepts. In some cases, we could still do that here, but that's not going to be one of our main focus for today. If we had to find that, we could solve it, but not all of these are going to solve real nicely, and so the x-intercepts may not be a nice whole number. If I had to find that, I could. The y-intercept, when it's in, I'll go ahead and mention this. The y-intercept, and this is not going to be an ideal point to graph here, but sometimes it may be, the c value is your y-intercept when it's in this form. So it would be all the way down at 0, -47. So it's going to be all the way down here at the very bottom of the graph. So that's not really a good point to graph, right? We're not going to graph 0, -47. Sometimes that would be a good point to use. It just kind of depends on what the number is. In this case, probably not a point that we want to use to graph. Okay, a couple of other things that they're going to ask us to do today. We already talked about this one a few minutes ago. Max and min. Okay, in this case, this is a maximum, and it happens at the vertex. So we would say that it has a max at y equals 2, and that happens at x equals 7. So the y value is always your minimum or maximum because that's the highest point that it reaches. 2 is the highest point it gets to, and that happens when x is 7. When it opens down, it'll always be a maximum. Okay. We've talked about domain and range a lot. We're really not going to talk about domain. You're not going to see a lot of the questions today ask you about domain. You might see it a little bit. The reason why it doesn't really focus on domain today is because what's the domain of any parabola? All real numbers. Okay, it's going to continue going left and right forever. Okay, so if it asks the domain, domain's easy. It's all real numbers. Okay, but it won't ask that very often because it's the same thing over and over again. If I ask you what the range is my y values, right? And it's going to go down forever. It's going to keep going down, and it's going to then, as I move up, it's going to keep going up until it reaches that high point of 2. And so my range here would be negative infinity all the way up to 2. And we would use a bracket because that's where it stops at. And then the last thing, this is also something that we've talked about a lot in the last chapter. Where does it increase and where does it decrease? Because this graph opens down, it's increasing on the right. As it moves from the left to right, it's going up, and then it drops after that point. So it increases up to the vertex and then drops after the vertex. Remember when we do increasing and decreasing, we're only going to use the x values. So it's going to increase from negative infinity all the way over until it gets to 7. And then at 7, it's going to change direction, and it's going to drop or decrease to forever or infinity. So those are a couple of additional things that you might see them ask today on some of the questions. And so there's going to be a few problems where they're going to have lots of different parts to them, where they're going to ask you different questions about the graph. If the graph opened up, then over here it's decreasing, and on the right it's increasing. So it would be just flip-flopped if the graph opens up. Okay, this would now be a minimum, and it's decreasing on the left-hand side and increasing on the right-hand side. Okay, that is it for today, graph and quadratics. If you want some graph paper, you can, but I think, kind of like I did here today, I think it's easier just to kind of sketch the graphs on your own. But if you want some, I think I have some on the counter over there. You can grab some if you would like to. I posted the answers to 3-1 yesterday. I'll probably post answers to 3-2 and 3-3 tonight, so you can start checking those if you want.